The next comic section we're going to talk about is the ellipse, which is that oval shape that we learned about in our introduction to this chapter. So we're going to be answering the questions: how can you identify the dimensions and orientation of an ellipse given an equation? We're going to write the equation of an ellipse given its vertices and covertices, or vertices and foci. We're going to find the foci of an ellipse given an equation. We're going to graph an ellipse in a coordinate plane given an equation. So there's a lot we're going to do here with these ellipses. Alright, so here's an ellipse. Just in general, an ellipse is a set of all points P in a plane such that the sum of the distance from P to two fixed points F1 and F2, that's these orange dots here, F stands for foci. Sorry about that. Okay, is a constant K. A focus of an ellipse, plural foci, is one of the two fixed points. So we just have, if you were to connect a string, any length of string, these 2 points, and you're to rotate it, you make this ovally shape. The shorter the string, the smaller the ellipse. And by changing the positions of the foci, you also change the shape. So the major axis, I'm just going to go ahead and throw all these vocab words up here so that I can draw on this picture and show you what each one of these means. Oops. Alright, so the major axis is, come on, you can work with me, technology. Alright, so the major axis is a segment that contains the foci and has its endpoints on the ellipse. So this is the major axis right here. This is the longer of the two. The midpoint of this is our center. The center of the ellipse is the midpoint. So this right here. The minor axis is just like the major axis, except instead of being the longer side, it's going to be perpendicular to that longer side. And its endpoints will be on the ellipse the other direction. We have vertices. These are the endpoints of your major axis. This one here and this one here. Those are your vertices. And your co-vertices are the endpoints of your minor axis. And it's not on here, but your foci are also along your major axis here, somewhere in between the center and the vertices. Okay, so that's all the parts of an ellipse. What's going on? I apologize. Apparently my internet is being very slow. Alright, so let's look at the properties of an ellipse with a center at 0, 0. So here are two equations that we need to learn. You don't need to know all of this stuff, so I'm going to point out what's important. So if you have a horizontal ellipse, horizontals goes this way, x squared over a squared plus y squared over b squared equals 1. Okay, the reason you can know it is horizontal or vertical is that A is always greater than B. So your A and your B values are going to determine whether this is vertical or horizontal. If A is underneath X, that means there are more X values, so it's horizontal. Whereas if we have x squared over b squared plus y squared over a squared equals 1, this is going to be a vertical ellipse because there are more y values because your A is bigger. Okay, A represents your distance from center to vertex. So from the center to the two vertices is your distance A. Now in the formula it's a squared, so when we're talking about distance A, we'll have to square root it. B is your distance from center to co-vertices. And then C is your focal length, which is what we've always talked about, or what C is always represented in this chapter. Okay, so make sure you write down those two formulas. And just as a thought, if your major axis is all the way across, A is from center to one point, two of those is going to be across the whole major axis. Same goes for minor axis. If from center to B, or center to covertex is B, then your entire minor axis is going to be 2B. Alright, so let's write the equation of ellipse. What's an equation in standard form of an ellipse that's centered at the origin with a vertex at -6, 0 and a covertex at 0, 3? Now remember, I keep telling you, always make yourself a little sketch just so you have an idea of what's going on. So we know we have a center at the origin. We have a vertex at -6, 0. I'm going to plot that. If we know that we have a vertex at -6, 0, we know that we have another vertex at 6, 0. And we have covertex at 0, 3. Means we also have another one at 0, -3. Okay, so here's our ellipse. Is this a horizontal or a vertical ellipse? It is a horizontal ellipse, so we're going to use the formula x squared over, we have more x values, so a squared plus y squared over b squared equals 1. Now in order to complete this formula, we need to find out what that a and that b are. So a represents from center to vertex. So from the center to the vertex, how many units are we away? Well, we're 6 units away, so a equals 6. Okay, now our b value is from center to covertex. So from center to covertex is 3, so b equals 3. So now all we have to do is square these, and we can rewrite these values in our equation. So a squared is 6 squared, which is 36, and y squared is 3 squared, which is 9. Here is your equation for that ellipse. X squared over 36 plus y squared over 9 equals 1. Alright, in order to find the foci, we're going to use what's called the Pythagorean theorem with a twist. So hopefully you learned in Algebra 1 that the Pythagorean theorem is a squared plus b squared equals c squared. Well, for an ellipse, in order to find our focal length, we take a squared and we subtract b squared. Then we take the square root of that. So what are the foci of an ellipse with an equation 25x squared plus 9y squared equals 225? Now, how does this one look different than the standard form that we've looked at so far? Well, the standard form that we've looked at so far always equaled 1. So in order to make this equation equal 1 instead of 225, we're going to divide everything by 225. Okay, and then we're going to reduce our equation. So I have x squared over 9 plus y squared over 25 equals 1. Now I have an equation that I can use. So it asks me what are the foci. So first of all, I need to figure out what my orientation is. Is it horizontal or is it vertical? Well, my a is always my bigger value. My a is under my y, so I know it's going to be vertical. We have center at the origin. We know b squared and a squared. So a squared is 25, b squared is 3. So we need to use our formula c squared equals a squared minus b squared. So that's 25, oops, sorry, that one's 9, minus 9, and 25 minus 9 is 16. Take the square root of that. So it means our focal length is 4. Now, in order to find, do you remember when we talked about parabolas? The focus is a point. So we need to find the 2 points that represent our foci. And they are 4 units away from our center, and they are on our major axis. So in order to find these points, we go up 4. So this is the point 0, 4. We go down 4. The point 0, negative 4. These are the 2 points of our foci, 0, 4 and 0, negative 4. Alright, this one is just the same thing. but this one wants us to actually graph it. So let's go ahead and do this one really quick. Uh, 36, x squared plus 100, y squared equals 3600. In order to make it equal 1, we divide everything by 3600. I get x squared over 100 plus y squared over 36 equals 1. Okay, so we know our center is at the origin, 0, 0. Let me grab a different color. Our center is at the origin, 0, 0. Okay, our a value is always the bigger one. This is a squared, so a equals 10. So that means I'm going to go horizontally 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 10 the opposite direction. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and I know that b is my other value. Take the square root of 36 and we get 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and then I'm going to make a smooth curve to connect those. So there's my ellipse. In order to find my foci, I need to use that formula, c squared equals a squared minus b squared. And a squared is 100 minus 36. 100 minus 36 is 64. Take the square root of those, so c equals 8. So that means I need to go 8 units from the center along the major axis. Remember, the major axis is the longer one, so this one. I'm going to go 8 units right, so that's the point 8, 0, and 8 units left. So that's the point negative 8, 0. These are my focal points, my foci. Alright, in this one, we're talking about a room that has an elliptically shaped ceiling called an ellipsoid. Have you ever been to the, the Capitol building in Washington, D.C.? I went there when I was in college, and they have this, on their tour, they talk about one of the rooms where they used to have their main gathering is an elliptically shaped ceiling. And some of the people from the Confederate Army were whispering to each other about plans that they had, and they happened to be at a focal point of this ellipsoid shaped ceiling. And another member across the room, who was actually on the Yankee side, he could hear what they were planning because he was at the other focal point. So, a little bit of interesting history fact. But in this example, you have an ellipsoid shaped room. So we have an ellipse. You're whispering back and forth to one another. You can hear messages. If the elliptical ceiling has a major axis of 120 feet, so that means from one side to the other is 120 feet, and a minor axis of 72 feet, one side to the other is 72 feet, how far apart are the foci? So what we're trying to find is, what are these 2 points in here and their distances? How far apart are these people away from each other while they're whispering? So in order to find that, we need to use this information. If we know what the center is, can we find what A is? Well, A is half of our major axis, so half of 120 is 60. And B is our minor axis, and half of 72 is 36. So we can find what our focal distance is. C squared equals a squared minus b squared. And 6 times 6 is 36. Slap a couple zeros on. And 36 squared is 1,296. When you subtract the two, we get 2,304. Take the square root of that. C equals 48. So what that means is, from the center of the room to one person is 48 feet. But the question asks, how far are they away from each other? How far apart are they? So from one to the other one is 2 of those distances. And 48 times 2 would be 96. They are 96 feet apart from each other. That's pretty cool that you can hear someone almost 100 feet away from you. Alright, that's kind of the same kind of question. You can use the foci that c squared equals a squared minus b squared in order to find a missing value. So in this case we have a is 8, c is 5. You can use that to find your b squared and plug it into your equation. This is a horizontal ellipse, so you're going to use x squared over a squared plus y squared over b squared equals 1 and plug in your values 64 and 39. Alright, that is all. I hope you had fun learning about ellipses.